Hey Math 10, I just wanted to show you a couple of tricky questions that some students have asked me about. So I thought I'd share with everybody the answer to how to do these things. It has to do with cube roots in particular. So one question that came up was the cube root of 1,000. And that's a question that I'd like to explore just to show you how to do it. It turns out you can use your calculator for it, and that's great. But I want to show you how you do it with 1,000 so that you can also do it with a question like 2,000. We'll do the cube root of 2,000. So let's start with 1,000. And yeah, you can definitely, again, don't get me wrong. Please calculate away. But again, it'll be helpful to see how it works for other questions. So you can take 1,000, you can look at sort of 1,000's DNA, if you will. You can look at its factor tree. And it really is sort of looking deeper into the number, its construction, its makeup. By doing the factor tree, you're starting to understand the number on a higher level so that you can do like weird questions like cube root of 1,000. So we can break that into, you can go however you want to do this. You could go 502, for example, and then 500 could be like 5 and 100. And then, we got 5 as a prime, 2 as a prime, so 100 could be like 10 and 10. And that could be like 5 and 2 and 5 and 2. So basically, we got ourselves 1,000 is equal to 2 times 2 times 2 times 5 times 5 times 5. You see how we have like 1, 2, 3 5s and 1, 2, 3 2s. Okay, so this is how you know. So when you take the cube root of 1,000, you're taking the cube root of 2 times 2 times 2 times 5 times 5 times 5. And a cube root is all about looking for things that multiply but to themselves 3 times in order to sort of give you what that root is, right? So like this fact that we have this triplet here is going to tell us what the answer is. This triplet here, that's going to turn into your answers. Because when you take the cube root of 1,000, you're taking sort of the cube root of this stuff, and when you take the cube root of 2 times 2 times 2, you end up getting 2. And you take the cube root of 5 times 5 times 5, you end up getting 5. So the answer is 2 times 5, because there's a triple pair of 2's and a triple pair of 5's. So that gives us 10. That's the answer. And that's how you do it. You can just kind of look into your factor tree for a number and analyze like the triples that you find. And if you find triples, then you just turn them from a triple into a single and then multiply the results. So that's how I did the cube root of 1,000. So you could also do the cube root of like 2,000 would be a little bit harder. And you'll see that it doesn't quite work out quite as nice. It's not that much different. It's just a little bit extra. So, we could do the factor tree for 2,000, but it doesn't really work out to be all that different. And I'll just mention that you don't actually have to go necessarily all the way down to the prime numbers. If you just find a triple, like you're pretty good to go. Like this works into 2 times 1,000. And if you happen to just notice that this was 100 times 10, and that's 10 times 10. If you sort of come to like a triple here, you actually don't really have to go all the way down to prime factors. So it's nice sometimes to just, if you stumble across or if you happen to recognize a triple that's already in it. So, this square root of 2,000 is also 2 times 10, cube root of 2,000 is the cube root of 2 times 10 times 10 times 10. So now I can take the cube root of each of those separately, and the cube root of 10 times 10 times 10, that's just 10. So it becomes 10 cube root 2. And the 2 really can't go anywhere, right? We're kind of stuck with that one. But that's why you can make this into a mixed root is the term. And that's a perfectly nice way to answer the question. You wouldn't want to go into decimal notation. You'd want to simplify it, simplify instead of evaluate. So that's how you might go about doing a question like that. Again, you're looking for the triples and the triples will, come out of that, out of the root and become just a single number. So that's my attempt to explain that. I hope that made sense, and if not, then, come on in, ask some more questions. We'll figure it out eventually. Okay, thanks everybody.